what happened? The average is here. Supposedly the maximum marks is over 68. So the average should be 34. So you can see at this side, this is the highest, about 9 students. And the lowest got someone, one participant only. You can see at this range. So for those who are here, please contact me after this and justify why you get these low marks, because you are the only one who get these low marks. And for the highest, there is no one get full mark for this section, but the 3 highest one is Aiman Haikal, Pang Seng Sun, and also Brian. So this is the mark. You can see slightly far from the highest, because you need to have another 4 marks to get highest. And for section 09, which is another section that I teach, there is 2 students get full mark. So I don't know whether you have problem or not, because last time I always ask, if you have problem, you can stay after your class and then you can ask me any question. And yesterday, what happened? A lot of you, I still try to loading to my myutm.my, still request service is temporarily unavailable. What happened to UTM Digital? You can see it is overload or under maintenance. Okay, yesterday, you need to imagine my situation. I handle 3 sections for digital logic, and others lecturer normally like 1 section, or the maximum is 2 sections. So the numbers of students they need to entertain is about like maximum is 60 students maybe, but mine it is 68. And if you imagine like maybe 10% of you are having a problem, so I cannot reply all yesterday. That's why I asked you to direct call me. And what happened is there is someone just informed me that he cannot find the question at 2 p.m. yesterday, which is the question is already start 2 p.m. but he just checked the e-learning. What happened? Don't you did some preparation before that? So last time in the Telegram group, we already informed you to check your e-learning, whether you get the similar view or not, but most of you didn't check, especially for those who did not take the mock test. Most of you call me and then WhatsApp me, I cannot see this, I cannot see that. Some of you even don't have the section 00 virtual hall. So that is all happen. Please make sure for final exam, this won't happen again. If there is information for you in the Telegram asking to check, then you directly check. Don't wait until beginning of your final exam, then you sit to your lecturer, doctor, I don't have this, I cannot see, I cannot open, I cannot view. So please learn from your mistake, and whenever we did a mock, please join. There is no saying it is not compulsory or compulsory. We didn't mention about it. So whenever we have anything that inform about your test and examination is very important. So okay, the lowest for this section, let me check, is 27.5. Okay lah, if compared to, there is one of my student get 24. which is the lowest. So for those who get this lowest, do you think that you can get A or not? So please make sure that you study hard and how you can get A, whether this marks is enough for you to get A or not. Because sometimes previous semester your senior get low in test, but then suddenly they improve in final exam. When final exam, although you get like 100 per 100, but if your test is low, you cannot get A. So please make sure that, because that is also have their percentage. That's why I see the test is also important. Don't just like, okay, this is just a simple test. This is a simple test. Okay, let me proceed with our next topic. Are you ready? I already start recording. Okay.
Doctor, before you start explaining your chapter, can you see the picture I sent in the group?
Picture?
Yeah, in the group. Also. How is that? Is an encoder like supposed to be output more than input? Like
Again. Your voice is breaking.
the output is 4 and the input is 1. How is it an encoder?
The output, the input is 1. The output is 4.
Is an encoder like decoder? The input will be less than the output, but the encoder input must be bigger than the output, right?
What is basically the question? The question is asking, is it correct or not?
What's the function? Yeah, like how is it in BCD encoder when there is only one input? It's supposed to be 10 or 16 input.
The input is 1. The input is 1. The output is 4. You look into which part? This is
the function X, right?
okay. The function is having output of 4, and then the input is 1.
Okay, encoder is supposed to be the input is bigger than the output.
Bigger than the output, the decoder. What is the function of X? Binary decoder functions. So you need to change from 1 to be decoder binary. Let me open the, wait, I need to open this one is module 3. Module 6. Because this is not my equation. Wait, I try to open back.
I got confused. I got it wrong.
Because the other section, they ask about different question, which is about the 7-segment decoder. That one is also quite confused. Finally. BCD decoder. What is the answer? Binary decoder.
No, the correct answer is encoder. Something BCD encoder is the correct answer.
Oh, supposedly decoder. BCD encoder.
I'm interrupting the class. Okay, just proceed now. Then
Yes,
I can.
but I need to look also for this specific, and then I can share with other lecturer about this.
Okay, okay. I'm sorry.
Because this is
Sorry.
many to many to small. Okay, what question this? Let me later on give to the specific person. Just now, yesterday, we also have several question, but it is related to another question about BCD decoder also. But I scroll up. The question is related to the which of the following statement are true statement. So that one, they did discuss.
Doctor, you didn't share the screen.
Yes, because it's a conversation
Oh,
on the lecture. Yeah. It's okay. I will forward the question, this one, and I will give to the specific groups. We're going to discuss first, okay, related to this
Oh,
question.
okay. Okay. Thank you, doctor. Sorry one more time for interrupting the class.
Okay. Okay, let me proceed with our module 8. Module 8, we have two, which is 8A and 8B. So for this module 8, which is related also to your previous one, which is about flip-flop. Okay, that's why before you can proceed to your module 8, you need to understand and remember all the flip-flop function. If you have like JK flip-flop, what is the table for JK? 0, 0, 0, 1, 1, 0, 1, 1, and then your Q is what? So like this, you have 1, 1, you have toggle, set, reset, and no change. And please also remember about your clock. The function of your clocks, that you have positive clock and you have the negative clock. How you're going to define the positive, how you're going to define the negative, because all these two changing will be given the different output. So this is area for your positive clock. This will be trigger for your negative clock. This is all what you're going to look into your module 8. And if you still remember for your project, group project, if you have a group project discussing last time, you know that you need to do the synchronized. Kenapa I punya pen ni slow? You're going to use the synchronized and also unsynchronized. You need to combine this together. I hope you already discussed the scenario. Scenario you need to decide first. Later on, you're going to look into the example, especially for the parking lot. What else you can see? The bomb timing. Okay, now we directly go to the counter. For counter, you need this for your traffic light. You need this for your, of course, for your calculator, for your leaf, for your vending machine. All are using counter from your basic digital logic. For counter, it can be divided into two, unsynchronized and synchronized. What is the meaning by synchronized? What is the meaning by unsynchronized? So both category can be differentiated by clock trigger, either it is positive or negative, count, binary decade, count direction up, down, or combined with up and down. So let's take a look first the difference between synchronized and unsynchronized. So you can see this is your sequential logic circuit. When you have the memory there, you have the memory, it's going to be a previous queue. Previous queue, this is will be feeding into your memory. And counter, you can see here, you're going to count like maybe from 0 to 1, from 1 to 3, from 3 to 2, 1, 3, 2. It depends on your situation, what scenario that you want to do. And the sequence also is not just going to up. Sometimes also can calculate to up. Let's say 0 to 7, 7 to 0. This is counting down, this is counting up. And you only going to trigger the changes for you to move to another by input pulse. Input pulse is your clock. Okay, this one you can just read it. But the most important first thing is I go directly first for your synchronized and unsynchronized. Synchronized, you're going to have same source for your clock. Unsynchronized, different source. How it look like? For same source, you're going to have like this. This is your clock. Let's say you have 3 flip-flop. So all of these are connected to the similar clock. But you can also have like this. When you have this connect to your clock, and this part, let's say Q or Q bar, this will be connecting to like this. This is another different source, because you can see this clock are depending on the output from this previous flip-flop. These clock are depending on your previous clock. So this is the first thing that you need to know about counter, synchronized and unsynchronized. So go back where you're going to use your counter. Where you're going to use your counter. As here is mentioned about parking. Let's say I have this space, and total number of this space that can use for parking. So there is a lot of parking. It is 500, let's say. And when you open your shopping mall, there is a input. Where is the entrance? This is the entrance, and you put the sensor here, entrance sensor. And there is the exit way when the car is going up. So there is another sensor here, exit. So here, when you have, let's say for the first morning, 8 a.m. So it is all full empty slot. But suddenly there is one car moving in. So one car moving in is going to count. You can see here, this is your circuit. The scenario here is you are the one who decide, especially for your project. Okay, I mentioned about project example here. And you can see you put the 4 level in this scenario. But you can just also focus on 1 level only, like what I did this here. So for this one level, level 1, So I have 500 empty parking. And then there is one car enter here. This entrance sensor will count up. So it will come out as 1. So one car inside. What happened is going to count as 1. And then it's going to compare into your maximum. Compare, of course, this will be minus to 1 here. And you're going to get 499. 499. As mentioned, you can have extra display. This is extra display, LCD display, right? So for here, let's say you connect to another display here to display the remaining space available. And then after that, there is another car coming in. So another 2 car already inside. So 2 car is going to plus another 1 is counting up. So you have here total 2 in your counter. And then you're going to compare whether it is similar or not, which one, whether it is more or equal or less. So if less, then how many free space available? If it is more or equal, you just put the full. Maybe here you connect to your display full. And then it's connect to the display full. For let's say there is a less than, you're going to compare, right? So how many that left? 198, because there is 2 car already coming in. 2 car, right? Because it's 2 times already up. And then this car, 1 car exit. So your exit sensor will count down. So this will be count down. After it's count down, you're going to compare with your existing value. So you're going to see it's going to minus 1 with minus, because you compare, then it will be 499 back. It's depend how many car in, how many car out. All of these from this counter, from the comparator, from this display here. This is the scenario that you did, but how in terms of the connection you need to create. The counter is what? Is it a flip-flop? Is it the latches? The comparator is what? Is it a marks? Is it a demark? So you need to create your own, okay? Another example here where you can use. Let's say you have 2 gates. Gates A and gate B. And the scenario, you must to open gate A first. So how you going to construct your circuit? To detect gate A first, and then after that open the gate B. This is about counter. So you can see here, you have also example of bomb. If let's say you pull the trigger, or maybe you press the button for the bomb and it start counting 1, 2, 3 until 20 seconds, and then it bomb out. So this is about the counter. And there is another example to generate the clock different frequency. By dividing the frequency, we can get, okay, this is also a counter. Later on, you will look into the flip-flop. This one is quite easy and the basic in your counter. So now, just now I already show you the big differentiation between synchronized and unsynchronized, because this is the most easiest to remember and the most important. How you're going to differentiate? About the characteristic of counter, you need to consider 4 things. So let's take a look one by one. First, about your synchronized and unsynchronized. Synchronized, same source, unsynchronized, different source. Similar what I draw. You can see this is synchronized. You are connecting to same source of clock. While for your unsynchronized, you are connecting first, okay, for your first clock. For your first clock here, this is FF0, FF1, flip-flop for FF, flip-flop 2, flip-flop 3. So this output will be Q0, Q1, Q2, Q3. How you define and
Doctor,
wait I got my student from space. Where is it? Sorry, Sadan, because my UTM space student are currently doing the S2. So one of the student asking a question. Wait, I need to contact using WhatsApp. Okay, let's continue. You can see here there is two different, which is synchronized and unsynchronized. Just now I already showed you. This will be your Q0, Q1, Q2, Q3. And for this part, you're going to put like this. Your final answer. So this will be your first flip-flop. This supposedly here. Normally, you're going to draw like this. As long as you know this is your first flip-flop. This is your first flip-flop. And this output will be your LSB. Remember LSB and MSB? In your numbering system, let's say I have a number of 197. This is my LSB. This is my MSB. So the final answer will be putting like that. And the first flip-flop will be connected to the initial clock. Okay, this is going to connect to the initial clock. But the rest, it depends, okay? It is not going to always look like this. it is not going to connect to the Q always, because later on you will have positive clock. Like this question is what? Negative, right? You can see this is positive clock, but you're going to look also on counting up or counting down. Maybe for the negative, it's going to connect from Q. But if let's say here is positive clock, you're going to get your answer Q0 and your connection will be like this. So there is also like this. Later I will give you a table for you to remember about positive clock, negative clock, and then counting up, counting down, how your flip-flop connection look like. This is the basic connection, just two of this flip-flop. From there, you're going to continue similar, connect another similar connection, okay, from the basic. So here for point number 1, you need to know synchronized similar clock, unsynchronized different clock. What is the meaning by different clock? Is it's going to use previous output. Either it is Q or Q bar. It depends on the situation, but it's going to be the next clock. Okay. Second, the counting. Is it the count up or down or maybe both? So here in the first picture, this is counting up from 0 to 1, from 1 to 2, from 2 to 3, and then it's go back. So it is counting up. This one, you are counting down. You can see from 3 to 2, from 2 to 1, from 1 to 0 is continuous and it is counting down. And for this example, you can see it can counting down, it also have a counting up. Counting down, counting up. For counting up, you can see from 0 to 1, from 1 to 0, from 1 to 2, from 2 to 3, and then go back to 0. While for the counting down, 3, 2, 1, 0. So you can see here at this side when it is one way, we call it as unidirection, only one direction. While for this part, we have bi-direction, which is we have two, whether it is up and down. For this, what is another differentiation? At here, there is no 1 or 2. You see? 1 or 0. Here you got 1 or 0. What is the purpose? Later on, you're going to use this. Let's say, if you are currently at 3, and then you were given with input 1, where are you going to go? From these 3, you're going to be given input 1. You're going to go for 2. Now you're going to go to 2. If the input is 0, where are you going? If your input is 0, from here, you need to check there is only 2 output side and 2 input side there. So you from means it's going to go out, isn't it? So if the input is 0, you're going to go to here. If the input is 1, you're going to go to this part. Sometimes there is also similar like this. Okay, from this, if you have the situation of 1, you're going to go to from 2 to 3. Sometimes if you have the input of 0, let's say, you're going to go from 2 to 2. This is also can be considered as bidirection. Okay, any question for this counting up, counting down? Okay, I proceed.
Uh,
Point
so,
number,
Doctor,
yes.
um, it counts from, so let's imagine it counts from 0 to 15, and then it goes to 15 and goes back to 0 again and repeat.
Yeah. It's
Okay.
depend. After this, you're going to see also there is recycle and saturate. Okay, if recycle is going to count back to the maximum, goes back and etc. Okay, if you going to continues, but this one it shows here on the differentiation between up, down, and also the combination of up and down. Later you're going to go to meet that you're going to have like recycle or maybe from zero and then 00, 01, 10, and then you have only this part and then you're not going to continue here. Maybe you just continue to this part only and then you're going to go here but you're not going to go this. It is depend on the situation and also scenario. Okay, so that is all possible. For this number 2 is just to know whether it is going to up or going to down on the counter. Okay, now here you can see there is about the limit, the range. If you are using 1 bit, of course you're going to have 0 and 1. For 2 bit, you're going to have 00, 01, 10, 11, isn't it? So all of this you can see for these 2 bit, you have 0, 1, 2, 3. So you have to the power of 4 minus 1 is going to be 0, 1, 2, 3. Continuous. This is counting up. And this is the maximum range. Range means from 0 to the maximum, from minimum to maximum. But in terms of sequence, it's going to repeat 0, 1, 2 until to the power of n minus 1. And then continues repeat again. For this counting down also similar from maximum to the minimum. Maximum to the minimum, minimum, and then it continues again. Okay, for this part is a mode or also modulus. This one easy for you to remember because it's depend on how many flip-flop that you have or maybe how many states that you have. Okay, for this example, you have 1, 2, 3, 4 means that it is mode 4. Okay, this one is also mode 4. So mode 4 means 4 states as following 0, 1, 2, 3. If you have mode 9, you're going to have 0, 0, 9. 0, 0, 0, 0, 1, 0, 0, 2. Wait. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Ada I skip tak? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Sampai 8 is mode 9. 2, 3, 4, 5, 6, 7, 8. If let's say you have another 1, 1, 0, 1, 0. Because it is mode 9. So you supposedly to have state 8. This one is 8, right? 1, 0, 1, 0. 4 plus 2. So all of these are depending on the value of your stages. If you have 9, means that from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 means 9 modes. And then what else? You have here maximum count. Okay, this one is similar. So N will be your numbers of flip-flop, or for the transcaded sequence maximum. So if you have, just now you have mode 9, right? Mode 9, how many N of flip-flop that you need to have? The maximum count should be 2 the power of N minus 1. If you have 2 the power of 3 minus 1, you got here 8 minus 1 is 7. So is it enough for mode 9? Of course not, right? So you can increase it to be 4. So here is 16 minus 1, you got 15. So it enough to get 9 stages. So some sort of that. And number 4, repeat the counting sequence. You can repeat. You can also just ignore and stop there. Whether the counter repeat counting sequence, we call as recycle if the counter goes back to the first count. Let's say you start with 0, 0 when you have count, and then this last stage will go to the initial value. Then it's called as recycle. For saturate, the counter repeat to the maximum until here, let's say it's 1, 1, 1. If count up, maximum count, if count up, okay. Or repeat the minimum is it the countdown. The counter repeat the maximum. It's going to repeat the maximum if the count up. And if let's say you count down from here until 0, 0, 0, it's going to repeat the minimum count only. Okay, it depends on whether it's a recycle or saturate. So we see the example here. Alhamdulillah, sorry, okay. You have AC, or called as asynchronized counter. We have the clock input. Okay, this is example. You can see unsynchronized. You have the clock that connected to the output of your previous flip-flop. As I already mentioned, this first clock should be your initial clock, your LSB side for your output. You can see here it starts from 0 and afterward until your MSB. Your SC also known as ripple clock, ripple counter. So it can be asked in your part A question for final exam. Maybe it said like, okay, the asynchronous counter also known as a ripple counter. So by using that question, you get 1 mark. So all for part A, as I already mentioned, normally it's asked for theory. Comparison asynchronous and synchronized. See the different clock. Where is it? Okay, this one you can see this is similar clock. Similar clock, as mentioned, it is synchronized. These clock are connecting to the output, so it is unsynchronized. Normally, your connection, the rest will be fixed, especially when you are using the JK. For JK flip-flop, if you still remember JK, you got here what? Q, 0, 0, no change, 0, 1 is set, 1, 0 will be 1, and 1, 1 will be toggle. So that's why you normally use this. You can see J and K are connected to the high. This one I think is going to connect to here also, because the things that we want to check is at this part, synchronized and unsynchronized. So normally it's going to connect to the high, connect to the high. This one I guess it's wrong, it's going to connect this, but it should be follow also the value of your output. depend on your wave. If it's depend on your Q, then you need to always check the value of Q. If let's say Q at that time is 0, then you're going to have 0, 0, no change. If at that time Q is 1, because you're going to have possibility of 0, 0 and 1, 1 only because it's similar, right? You cannot have 0, 1 or 1, 0. So it will be toggle. So depend on your Q for this type of flip-flop. Okay, cannot move. Okay, now you have here the example. Okay, this one is looking at the positive or negative side. It's okay there. This is the most important, as I mentioned. You need to remember this table. First thing, the basic on your positive edge. You can see here, this is positive clock, positive clock. If it is counting up, you need to connect Q bar, previous Q bar to the clock. And if it is counting down, you need to connect to your Q, previous Q to the clock. While for the negative, it will be vice versa normally. If it is negative, counting up, you're going to connect to the Q, previous Q of course, and if the counting down is going to connect to your Q bar, previous Q bar. Going to see the example slightly easier for you to remember. Okay, this is unsynchronized because it's going to connect to your previous clock, previous output. LSB is the first one. It's going to connect to the clock there. This is about point number 1. Clock for FF come from your previous FF. See? That is about here. And you can read 3, 4, 5. Now I'm going to show you the example. Ignore at the bottom part first. You have the example for count up to be unsynchronized counter. Count up. Go back to here. For count up, what happened? Count up, positive edge. You need to connect to the Q bar, previous Q bar. See, it's going to be similar. This is the most important. You can see here. Okay, the rest will be like connect to the high there. And high there means that J and K is always 1. It depends, sometimes it's not going to be like this. It's maybe going to connect to the Q or whatever wave is give here. J and K maybe it's going to put the wave. But for this question, you give directly for the high means this situation. What happened to JK and J and K is 1? It's going to be toggle. So it is a positive edge. What you need to do? You're going to draw the positive edge. Assume the Q initial is low. Assume it's to be low first. And I always ask you to draw the dotted line at the positive clock because this is positive edge. Now starting from 0, 0, you meet your positive clock. What happened if you meet here? You're going to check your input. What is your input? 1, 1 is going to toggle from 0 to 1. Here, until here, you meet your positive clock. What you're going to do? You're going to refer to your input. What is your input? 1, 1. It's going to toggle. From 1 here, you're going to toggle to 0. Continue until you meet another positive clock here. You refer to your input. What is the value? 1, 1. So you're going to toggle again from 0 to 1. And then you continue until you meet another positive clock. What will happen here? You're going to check your input. What is your input? 1 and 1 is going to be toggle from 1 to 0. You done this part. Finish about like, okay lah, 2 marks you get. Now we should continue because we just finished at this part, right? We just finished at this part. We just finished getting our Q0 now. And next, you can see the next clock is going to refer to your Q bar. That's why you need to draw a Q bar. Q bar is always toggle from your Q. So you get this, okay. After you get this will be your clock 1. This is your another clock. What you need to do, this one is positive. You need to draw a positive clock there. Okay, I need to change my color. This is my positive clock. Salah, sini tak ada. So only this is my positive clock for my next clock here. So draw the dotted line at this specific point. So I'm going to do the similar one flip-flop. What happened? Starting, I'm going to get 0. It's going to be 0 until I meet my first positive clock. I'm going to do what? I'm going to refer to the input. My input is 1, 1. It's going to be toggle. From 0, you're going to toggle to 1. Move until you meet your positive clock here. You refer to your input. What is your input? 1, 1. You're going to toggle from 1 to 0 until finish. Any question for this part? Hello, any question? I buka mikrofon ke tak ni? Ke you all dah terkeluar ke I yang dah terkeluar ni?
Doctor,
Okay.
can you repeat how to calculate the Q0?
Okay, that one is from your module 7. Kejap I delete dulu. Don't look here. This is your normal flip-flop from your module 7. From your module 7, if you still remember JK flip-flop, you got the table. I asked you to remember if 0, 0, what is your Q? You're going to have no change. If it is 0, 1, you're going to have reset. If you have 1, 0, you're going to get set. If you have 1, 1, you're going to do toggle. This is your module 7 flip-flop.
Doktor, saya ada soalan lah.
Ini I punya student space ni. Aduh, hai. Sekejap I nak suruh student space I tunggu jap. Okay, so over here, you can see this is from your module 7. From module 7, I asked you to remember this table. We already justified how and why we get this summarized table. So what you need to do, you need to remember, this is only flip-flop for here. I asked you to ignore this first part. This is normal flip-flop. What you need to do, it is a positive edge, initial is low. So initial low, positive, 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 positive. You just change the output when you have the trigger of the positive clock. At this specific positive clock, you need to refer to your input. Then you can see your table. This is your input J and K. Our input for J and K is fixed, high. High is this part, 1, 1. Your output will always toggle, output of Q. So from starting is 0. When you meet here, you check your input is going toggle until you meet another positive here. You just trigger your output when you have positive. When you have positive. Then you trigger again, look into your input. Your input will always similar to toggle because of this condition and connection. So you toggle, you meet another active high, positive. You're going to have positive, refer to your input which is similar 1, 1. You're going to continue toggle similar to this one. After you finish done for this flip-flop, you get this output. You're going to toggle for your Q bar because this will be another flip-flop for you. But this value of clock is depend on your Q bar now. This is your Q bar. And it will be your next C, next clock. And refer to this is going to be positive clock. For positive clock here, then you're going to change your output, refer to this flip-flop JK table. So you only trigger when you have positive clock there, toggle, positive clock there, toggle. Okay, now understand or not?
Understand, Doctor?
Okay, wait, I need to, can you take a break first? I need to go to my COA class. Wait, I need to mute. Okay, hi everyone. We already take a break. Let we continue. Saya belum share screen. Okay, can we continue now?
Yes, doctor.
Okay. So we have here, just now I already shows you. Now we're going to look into next example. Okay, before we go for next example, you need to see you have cycle 1, 2, 3, 4. At this cycle 1, what is the value of Q1, Q2? Q1 is 0, Q0 is 1. Q1 at this cycle 2 is 1, and here is 0. Q1 is 1, and this is 1, and lastly 0 and 0. So you can draw the table cycle 1, 2, 3, 4. At this part, it's going to get Q1, Q0, 0, 1. Correct me if I wrong, copy. This one is 1, 0. This one is 1, 1, and this will be 0, 0. So you can draw the diagram. It's going to move like this, it's going to move like this, going to move like this, going to move like this. You can see it's like counting up, isn't it? 0, 1, 2, 3. So you can draw the table, and also you can draw the timing. The timing diagram is not showing here, but it's okay. Let's take a look another example. Okay, we have here 2-bit also for our counting up. This is all hidden for you, and it's going to use JK flip-flop and negative H trigger clock. Okay, let me draw first. Question number 1, draw the connection of logic symbol. If I want to see, I forgot already negative and counting up. Negative counting up is going to be connect to my Q. So let me continue drawing. Okay. I'm going to draw my JK. This is my J and K flip-flop. And my counter, I'm going to connect directly to the high. J, K, 0, 0, F, F, 0, F, F, 1. And we have here J1, K1. Okay, done this part. And we have negative H. Our clock will be got the bubble there. Got the bubble there. And first is going to connect to CLK. And the second one is depend on your scenario. Counting up, negative H going to connect to your Q. This one is Q bar 0. Here will be Q1 bar Q1. So this is the first thing that you need to do, draw. Second, draw the waveform of 5 clock cycle. So you need to draw the cycle. Apa yang nak buat dulu? Okay, I draw dulu. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it will be negative. Negative, 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 negative. Okay, done for this part first. Supposedly, our initial Q will be informed. So in this question, it forgot to inform, we assume it's to be starting as color apa? 0. Okay. Our Q0. This is your first flip-flop, module 7. If you can't remember, I draw the table JKQ. This is your output for your Q0 after this. And this is your JK0 because we are referring to this one. If we have 0, 0, 0, 1, 1, 0, 1, 1, this will be toggle, this will be set, this will be reset, and lastly, this will be no change. Okay, this one is when you're going to trigger this, when my negative H occur. So it will be changed only when I meet my negative clock. Okay. So I done this part. Let me draw the initial value is 0. I'm going to continue until I meet my negative clock here. Kenapa dia buat macam tu? Okay. I'm going to check my what? Input. My input is what? My input is high. This is for counter. Last time you already looked for the counter. It's going to connect to high. What is high? High is 1. 1 for the J, 1 for the K. Means what condition? Toggle. For your output, Q is going to toggle. So it's going to toggle from 0 to 1. You continue until you meet the next negative clock. You refer to your what? Input. What is your input? Similar. 1, 1. So what you're going to do? You're going to toggle. Continue until your next clock. What happened here? You're going to toggle. You're going to continue until your next clock. What happened here? Toggle again. And so on. This toggle condition will happen if it is ripple counter because you have connect to high both. If your J and K is changing the value, you need to refer to all these one, similar to your module 7. Okay, you done this part. You need to get until Q1, isn't it? Now, you can see you're going to refer for this section. You already finished this one. So for this side, you change this J, K as 1, 1, 1. So, but it's still similar. It's going to refer to the toggle because this connection are connect to high there. But my clock here now are connecting to my Q0. So this will be my next clock 1. What happened? I need to see this is negative H. I need to draw the negative side. Oh, there is only 2. So starting from this is Q1, starting is 0 until I meet my negative clock here. I refer to my input. My input is similar, which is toggle. Until I meet my negative here, I need to refer to my input. My input will be toggle. So this is my output Q1. You have 5 cycles here. So cycle 1, cycle 2, cycle 3, cycle 4, cycle 5. This one is done, this one is done. Now you need to construct table. At this What is the value? 0, 0. Here will be 0, 0. At number 2, it's going to be 0 and 1. 0 and 1. At this cycle 3 is going to be 1, 0. At this cycle 1 is 1, 1. And my cycle 5 is 0, 0. So what happened? You can draw 0, 0, 0, 1, 1, 0, 1, 1. So this is my state diagram. So let's take a look in a proper and beautiful way. But it is basically similar. You can see this is the one that I draw, the clock. I need to have negative. So my Q here will be only change as my negative side, and it will be always toggle because it's connected to high. And then after that, when I finish with my Q0 there, I need to make this as the second clock.
Doktor.
Ada sudah saya ni. Sekejap eh.
Oh, doktor.
Ayo, hey student, sekejap eh. Okay, now here is the answer, right? Just now I already shows you. You have this clock, and then you need to draw a kenapa. Just now it's 5, but it's okay. It's basically similar. You can also draw 5. You can also draw 6, 7, just to see what is the output. It's going to be continuous, okay? And for this part, you're going to only look at here. Basically, the single flip-flop you learn in your module 1 and module 7. After that, you can see this clock for second one. This will be your next clock here. Then you're going to see your question is negative. Negative. At this part, you're going to trigger the changes. It's going to be all toggle because it is 1. After you get this timing diagram, you can draw all cycle value to the table like this. This is a stat table. The name is what? Stat table. After your stat table, you're going to draw the stat diagram. This is the stat diagram. All of these.
Doctor, can I ask a question?
Yes, sure.
How can you know if Q0 and Q1 initial value is 0 or not? Is it fixed 0 always?
Oh, as I mentioned, normally in question it must mention what is the initial value.
Okay. But this question, I think, didn't, right?
Yeah, this question is didn't write the initial value. Just now I already mentioned also.
Okay.
There is no mention on the initial. But you can see here at the beginning, it's already put in the question. But in terms of at this question, it's not showing.
Okay, got it. Thank you.
Okay, so next, maybe if you were given like this question, you can ask your lecturer, is it the initial is to be assumed as 0 or not? But should be normally we will give the initial value. Just to make sure you are not confused with the question. Okay, I give you another example here. Now we have 3 bit. This is our hint. 3, of course, we're going to have 3 flip-flop. And it is a counting down. Counting down negative age. Counting down negative age. If you refer back to this table. What is the table? Okay. Counting down negative age. You're going to connect your next clock to your previous Q bar. So now you have slightly more challenges because you need to have a Q bar. But when you know and remember this basic connection, you can connect with many clock after that. Many flip-flop after that. Oops. Okay, here you have 3. You use JK flip-flop and it will be negative age. I draw my flip-flop here, slightly small, okay? Okay, I have my flip-flop and I always connect my J and K to my high. First of all, it's going to be K0, J0, FF, 0. Next is FF1, FF2. Here will be my J1, K1. Here will be my J2, K2. Done for this part. And first, I'm going to connect my clock, negative clock to my CLK. My negative clock here, my negative clock here. This clock will connect to my previous Q bar. This clock will connect to my previous Q bar, and this will be my Q0, Q1, Q2. Okay, I done for my question number A. Question number 2, it asks you to draw the waveform of 8 clock. So I have 8 clock, 8 cycle. Okay, 8 cycle. Let me draw somewhere here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, done for this 8 clock cycle, and it is negative. Negative, 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 negative. Done my negative part. I want to draw the dotted for my negative here, because I'm going to trigger changes at the dotted line only. This is my Q. Okay, wait. Slightly small. Q0. Q0 at this part only, similar to my JK0001111 toggle. This one you fill it by yourself for your Q0. Okay, we look into this toggle. No need for me to repeat again because it's always high for your J and K. Initially, I assume it to be 0. I'm going to continue until I meet my negative clock here. I need to refer to my input. It is 1, 1 is going to be toggle. And I continue again, I'm going to toggle. I continue until I meet another negative clock. I'm going to toggle. I meet another one. I'm going to toggle. I meet another one. I'm going to toggle. So I'm going to toggle at every negative clock only. I done for my Q0 here, but my flip-flop clock for F1 is connected to the Q bar. That's why I need to have Q0 bar. So it will be toggle every output. Toggle from what? Of course, from the Q. Okay, done here. What happened? We done this part. We're going to move for this. We're going to look into our flip-flop clock here. What is our clock now? Our clock still negative. It's going to at this part, this part, this part, this part. 1, 2, 3, 4. This is our Q bar. Our Q bar will be my CLK1 now. I'm going to draw the dotted line here, the dotted line here, the dotted line here, the dotted line here. Why? Because this is my clock and this is our normal 1 JK flip-flop like what we learned in our module 7. The output will be Q1. Q1. Q1 assume as it's starting as 0. And you can see here, this is our negative clock. It's going to be toggle until we meet another negative clock. It's going to be toggle until we meet another clock here. Negative clock, sorry. Until we meet another negative clock. Then finish for our Q1. What happened for our next? Because we want until Q2. This one will be using the Q1 bar. That's why we need to have Q1 bar. I'm going to toggle from my Q. Done. So next, I'm going to, this one is finished already. These two also. So this one will be connect to my Q1 bar. This is my CLK2 now. And I still remember it is a negative H. This waveform will be my next clock. Negative, negative, finish that one. So I have Q2. Starting from 0, it's going to toggle again. It's only toggle at the negative clock. You can see here. It's only toggle at negative clock. And this is my answer that I need. Q2, Q1, Q0. Look at the specific cycle. Cycle 1, you have 0, 0, 0. Cycle 2, you have 1, 1, 1. Cycle 3, you have 1, 1, 0. Cycle 4, you have 1, 0, 1, and etc. So you can draw the table of state table after that timing diagram. You can see here. This is the similar things that we have. And this is the table from the timing diagram. And you need to draw the state diagram for the counter. Following this one, you can see this, and then continue to here, and cycle 2, cycle 3, cycle 4, 5, 6, 7. This is cycle 7, and lastly is 0, 0, 0, cycle 8, which is continue again. Okay, any question for this part? Siapa yang chat tu? Who typing the chat? Can you let Brian enter? I didn't receive any. Is he in already? Because he's supposed to auto. I already went in auto. I don't know what happened to the Google Meet. Okay, I want to continue. Oh, this one I don't want to cover today. Okay, any question for this part? Any question for the counter? You need to understand before you can move to another subtopic. Maybe I can show you. This one is 4, right? Just now. Where are we currently? Okay, this one is 2. And this is example of 2. This is example of 3. Example of, okay, it is not showing. Let me show you the example of 4-bit. For 4-bit here, tak boleh. Kenapa dia tak show? Oh, because I didn't show this one. It's okay. I can continue here. You can see here. This is if you have 4-bit. If you have 4-bit here, you can have 4 flip-flop. 4 flip-flop, 1 flip-flop, 2, 3, and 4. And from here, what you need to do, you can draw the clock. For this clock, first clock as this one. So you have altogether 16 cycle. And then you're going to do and continue your Q. You can see Q0. How you get your Q0 starting at 0? This one is negative, 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 negative. You continue until the rest. At this specific negative, you're going to do a toggle thing because this is negative. When you got this one, this Q0 will be your next clock. You can see, this is our next clock. Because of this, you're going to draw the negative clock here. Referring to your negative clock there, you're going to get your Q1, but your Q1 will be triggered only when you meet the negative clock. Still similar, you're going to do the toggle things because your input is 1, 1. Finish for this part, you can see your Q1 now will be your next clock to get your Q2. So your Q2 will only change when you have the negative trigger there. Negative, negative, still doing the toggle. And lastly, when you have Q2, this will be your next clock for your flip-flop 3 to get your Q3. So Q3 will be only toggle when you meet negative clock here. And negative clock here. You can do, if you have 5, you can have 6, you can have 7 flip-flop. All will be continuous, similar. Okay, any question? And then after that, you're going to draw, of course, your table and then your timing and also your state diagram. Any question? So tomorrow we're going to look into unsynchronized ticket counter, which is you can jump there, jump here and jump there, which is not following the sequence. Okay. So what is needed, maybe later on you can see, oh, this is the modular stand, how it's going to look like, it's going to refer to that NAND. But all of this, I will discuss with all of you after you already master and understand all this counter. You can see we just have a few more slides tomorrow, but we're going to directly also to continue with module 8B after we finish. There is a calculation. The calculation also important for your final exam. As I already mentioned, I'm the one who prepped for question for module 7, 8, and 8 for your final exam. So I know which one is coming up, which one is important. Okay, any question? If there is no more question, I guess we can dismiss now. We meet again tomorrow because I need to also conduct this COA class. Wait, I tried to log in to my, done now. Wait, I need to get the QR code for you because I can log in now. Okay, I'm going to share you the QR code. Please scan your QR code. For the rest who already scanned, you can leave. Thank you for your participation and have a stay safe day. Bye-bye. Ciao, eh? Thank you, Doctor. Okay.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Okay, bye-bye.
Thank you, Doctor.
Okay, bye.
Thank you, Doctor.
Okay, bye-bye.
Thank you, Doctor.
Okay.